Students, our next topic is about solutions, suspensions and colloids. Okay, so here what are their properties, actually what they are, now we will learn. So before going to learn what are solutions, suspensions and colloids, we will learn one more thing, that is what is solute and what is solvent. Before learning solution, suspension and colloid, we should know two meanings, two words meanings. What are the solute and solvent? Generally, when we are making any solution or suspension, one liquid should be there and one substance we will add there. Isn't it or not? So here in that solution, which one will call it as solute, which one will call it as solvent is substance which is dissolved in a liquid to make a solution. The substance which one we are going to dissolve. For example, take salt solution. Okay, which one you will dissolve in the water? Salt you will dissolve in the water or not? So, salt is the substance which is going to be dissolved in the water. Isn't it or not? So, in our salt solution, which one is solute? Salt is the solute. Okay, then what is solvent? Liquid in which solute is dissolved. So, what is solvent? In which liquid we are going to dissolve the solute, that liquid we will call it as the solvent. Clear? So, here solute, another name we can also call it as dispersed particles. And solvent, another name is dispersion medium. Clear? And if any solute, means different types of solutes are there, salt, sugar, so many chemicals are also there. If any solute is going to dissolve in water, that type of solutions will call it as aqueous solutions. And if some solutes will not dissolve in water, if they dissolve in organic liquids, if some solutes dissolves in organic liquids, that type of solutions will call it as non-aqueous solutions. Clear? If any solute dissolve in water, aqueous solution. If any solute dissolves in organic solutions, that type of solutions will call it as non-aqueous solutions. Clear? So now we will study the what are solutions, suspensions and colloids. Okay, solutions means if something we will say it is a solution, it should fulfill some properties. It will have some properties. Then only we will call it as a solution. There are so many solutions: salt solution, sugar solution, copper sulfate solution. So many solutions are there. Sea water. Like that, so many solutions are there. So here, if we talk about the solutions, see, first one, it is a homogeneous mixture of two or more substances. For example, take sugar and water. Okay, you mix it. After mixing it, can you differentiate which one is sauce, which one is sugar particle and which one is water particle? No, they will be completely mixed with each other or not. They will not have any separate boundaries, isn't it or not? Completely they will be mixed with each other. So, the solution, if we are telling something in solution, it will be having, it is a homogeneous mixture. And second one is, the size of the particle will be extremely small, very small, very small. Very small means how much it is? Less than 1 nanometer. What is the size of the particle of a solution? It is less than 1 nanometer. 1 nanometer means you know how much? 10 to the power of minus 9 meters. Means extremely small. Even we are unable to see even with microscope. Okay, that much small. Even we are unable to see with the microscope. Do you find any sugar particles settling down? No, na? They are completely mixed with each other. Isn't it or not? So they are very stable. And even they does not scatter light. Does not scatter light. This point we will discuss last. Okay. So up to here clear now. So come to suspension. What do you mean by suspension is? It is a heterogeneous mixture. So here I am taking one example as water and chalk particles or sand particles. Okay. When you mix those things, sand particles and water, can you easily differentiate or not? Two separate things we can differentiate or not? Sand particles will be able to identify, water is also will be able to identify. So they are not completely mixed with each other in a suspension. And the particle size is quite large. Even easily we can able to see the particle size. How much the particle size will be there? Larger than 100 nanometers. Once particle size will be more than 100 nanometers. And they can be seen. Easily we can able to see. No need of microscope or anything. We can able to see with our eyes. And do not pass through a filter paper. That particles, water will be there when we are keeping filter paper and when we are pouring that water and chalk particles mixture, the water will pass downside and that chalk particles will be separated there, will be left over there on the filter paper, isn't it or not? So here they cannot pass through the filter paper. And next one is unstable. Unstable means, okay, leave that chalk powder and water solution for half an hour. After half an hour you observe that water will come outside, the chalk particles will settle down or not? Isn't it or not? So they are unstable. And next one, scatters beam of light. Okay, last we will see this one. And next come the colloids. Which type of mixtures we will call it as colloids? If for example for this is soap solution. Okay, tell me that when you take some soap and dissolve in the water. Okay, do you feel that solution is transparent? No. If you will observe salt solution or sugar solution, it will be transparent. But if you will observe the soap solution, it is not transparent. Okay. So here, actually what happens is it appears to be homogeneous. Colloids means, colloidal solutions means, they look like homogeneous but they are heterogeneous. There will be little bit soap particles will be left over there. We cannot see the means. It appears to be homogeneous, but actually colloid is not a homogeneous, it is heterogeneous. And next one is bigger than the particles of the solution and smaller than the size of the particle of the suspension. Means what are particles into there in the colloids now? That their size is bigger than the solution particles and smaller than the size of the suspension particles. So around the particle size in colloids is between 1 nanometer to 100 nanometers. And third one is they cannot be seen. Means most of the colloidal particles we cannot see with the help of the microscope even. Okay, most of the colloids we are unable to see even with microscope also. Next one, they can pass through a filter paper. Same just as in solutions, they will pass through the filter paper. Even if you are using filter paper, you cannot separate soap particles and water separately. Complete solution will go through the filter paper. And they are also quite stable. Even though you are leaving for 1 hour or 2 hours, we cannot find any soap particles settling down. Okay. And next one, scatters beam of light. Here, the only difference between solutions and colloids is the last point. What is that? The true solutions, they does not scatter light. Whereas in colloids, this scatters beam of light. Here, example is, for example, take one, okay, some glass beaker or glass and take some, okay, here some torchlight is there. Same here also. Same here also. outside we are able to see the light, and that side also we are able to see the light. Even inside the beaker, means this beaker is containing suspension now. So inside the beaker also we are able to see the light. Why? Because here the size of the particle is quite larger. They can able to scatter. They can able to scatter the light outside. Because of that scattering only we are able to see the light here. Same thing we are observing here. See, inside light, inside whatever in the beaker, we are unable to see the light inside it. Here we can observe, and this side also we can observe, but here we can't observe. Why? Because here the particles are very small that even they are unable to scatter the light. Okay. Since they are unable to scatter the light, we are unable to see light in the beaker. Even if you will see the colloids condition, here we can able to see the light. Why? Because comparing the solution, the size of the particle in the colloids is larger. Bigger, the size of the particle is big in colloids. So here, since they are bigger in size, they can able to scatter the light. So this is the only difference in colloids and solution is they are unable to scatter the light since the particles are very small. Here in colloids they are able to scatter the light because the size of the particle in colloid is little bit bigger than the solutions. Okay, so here this scattering effect of light. This scattering of light by colloidal particles. This scattering effect of light by colloidal particles only we will call it as Tyndall effect. What is this effect? Tyndall effect. The scattering of light by these colloidal particles only we call it as Tyndall effect. Okay, so this is about the properties of solutions, suspensions and colloids. Okay children, up to here make your notes and read thoroughly. Thank you.